Alright, so I asked you to add the numbers from 1 to 100, the integers. So I'm going to go over really quickly the strategy for how we're going to do that. What I'm going to do is in red write that sequence of numbers backwards. So I'm going to go 100 plus 99 plus 98 plus 97 plus ... plus, and then it's going to be, I got to end with 1, so it's going to be plus 3 plus 2 plus 1. Now I can add those lines. What do I get when I add these two? I get 101. What do I get when I add the next two? I get 101 plus 101 plus ... I'm going to get 101 every time. So what you can then do is look at how many 101s we have here. Well, what's the best way to figure out how many 101s I have here? Well, look, I can count them up right there. How many do I have? I have a total of 100 of them. So I can do 100 times 101. That will tell me how many 101s I have, or what these 101s add up to. Now, what I want you to see is that is not this sum, because I've got that sum in black, but then here I've got it in red. So what I've done is I've taken the sum twice, and that adds to this. So what I need to do is divide this by 2, and that gives me 50 times 101, which I think is 5050. And that is the quick way to go and add those two sequences. Or sorry, to add this sequence, the numbers from 1 to 101. Right, so I want to quickly talk about how I could generalize this. This was n, the number of terms that I had. This was the first term, a sub 1, which was 1, plus the last term, a sub n, which was 100. And then that 2 is always going to be there. So what do I get? My s sub n, which is going to be the nth sum of a sequence like this one, which I call this arithmetic. It's got what we call a common difference everywhere. There's a gap of 1 between each of these numbers. So for an arithmetic sequence, s sub n is the number of terms times the first term plus the last term all over 2.